Okay, good afternoon, PCD. First of all, wow, y'all are so talented, and I am so inspired by all the brilliant work going on here. And second, thanks for hanging with me till almost the very end. I hope this is mildly, at least, practical for you. I want to share with you some of the work I did for my master's thesis in geography at the University of Oregon, which entailed a lot of mapping, but without a map, and I can explain. I wanted to investigate, where's my mouse here? I wanted to investigate the relationship between migration data in North Carolina and elections on the ground results in the elections in the state. I wanted to answer basically the question, are likely Democratic voters, for example, moving to certain places more than others? What about likely Republican voters? And is the trend pervasive enough that it amounts to anything? Does it matter that people might be doing that? And so I needed, I'll be honest with you, the best data for this does not exist. But I needed a few things to try and get a handle of these questions. The first thing I needed was raw migration data. That is, how many people moved from X county to Y county? Pretty straightforward. And I needed to know the political affiliation of these migrants, which I do not know. But the US Census does publish sometimes the educational attainment of migrants at the county level. And fortunately, this is due to some fortunate celestial alignment, Pew also published data on the specifics of the relationship between educational attainment in North Carolina during the time period I was studying, which is crazy, so perfect. So I applied those proportions to the migrants for the final piece of the project. If you have questions about the methodology or the results, ask me after or later or over a beer, whatever suits you. In any case, political affiliation does not turn on a single variable, and it's rather a result of something much more complex. So I'm happy to talk about that with you later. Finally, I needed to situate that around on-the-ground political change. Who is actually winning elections where at the county level? And with all of that data, we can ask ourselves one big question. Is there a relationship at all between educational attainment in terms of on-the-ground political change and migration in the state? And that is to say, are migrants with advanced degrees moving to certain places, moving to counties that are becoming more Democratic or more Republican? What about migrants with a college degree or a high school degree? And when we talk about elections and electoral breakdowns, we do often talk about that stuff. We talk about education, we talk about income, we talk about ethnicity, and those things can also shape where someone decides to move. So I pulled the migration data, and it's like a lot of data, like 12,000 rows for North Carolina, a lot of data. So I not only needed a visual that would take into account those three pieces, but also a process that I could scale easily to apply to all 50 states, because that is my ultimate goal. And after a lot of tinkering and talking with people who are way smarter than me, I decided to use Sankey diagrams, which is one of these little guys. So I want to get into the how-to, but it's important to explore what these visuals can offer us and why they're such a good fit for this project, why we're replacing a map with a decidedly not map. And as I mentioned, I wanted to consider whether there's a relationship between trends in migration and on-the-ground political changes. But there are a lot of ways to define on-the-ground political changes. And I explored a few different measures, but I settled on the one that I thought was most interesting and actually the most appropriate, which I was calling the Republican change variable, which is just answering the question, in what counties has Republican support risen and fallen over the course of 5 presidential elections between 2000 and 2016? So we have these 3 counties where Republican support has fallen by more than 15 points. Those counties are home to Charlotte and the Research Triangle, for context. A handful more where Republican support went up by up to 15 points, and then the rest fall somewhere between those 2 extremes. So I'll remind you, of course, that counties where Republican support has fallen aren't necessarily Democratic counties. This just captures the change over time. But because these counties aren't contiguous, it would be difficult to map the flows between all 100 of them. There are 100 counties in North Carolina. So that's what makes the Sankey diagram a really useful alternative. We can highlight the flows of movement between counties that share a feature. And this is how you read a Sankey diagram. So if we look at line A on the map, that's the migration pattern, the migration flow of migrant A. They moved from a low-loss county, a county where Republican support has fallen by up to 5 points, to a high-loss county, a county where Republican support has fallen between 10.1 and 15 points. So every migrant in North Carolina that moved between those two types of counties are shown in aggregate by ribbon A on the Sankey diagram. And the same for line B. So a migrant moves from a low-gain county, a county where Republican support has risen by up to 5 points, to a very high-loss county where Republican support has fallen up to more than 15 points. And those migrants are shown in aggregate by ribbon B on the diagram. But the real power of these comes when you compare them. So let's go back to the one we were just looking at. This shows us the migration flows of people with an advanced degree between these groups of counties. And it's very clear that most migrants are moving from and into counties that have become substantially less Republican over the last 5 presidential elections. And the trend is similar for those with a college degree. The dark blue on the left dominates the chart. But that differs significantly when you compare it to the Sankey diagram for migrants with a high school degree, or less than a high school degree, where the distribution of migrants more closely reflects the distribution of population in these groups of counties. And there are differences when we consider income as well. Migrants with incomes at or above $150,000 a year are overwhelmingly likely to be moving into and from counties where Republican support has fallen by more than 15 points. And the difference is clear when you compare it to the migration patterns of migrants with incomes between $15,000 and $25,000. These visuals really offer us that. And education and income, among other demographic features, have a role to play in shaping migration, and those things themselves are not separate from politics. So it's important to study them together and to visualize them together. And that reality really isn't visible until we situate it in this way, and using a not map to map migration. So with that, we can chat about the process. So how did we get from here, this is the raw census data, to here? And the answer is really just R in Illustrator, and Courtney has already given us a great look at how R works. So for all of those who are big fans of R also, I'm drawing mostly on the tidyverse and parsetR libraries. And it's basically a 2-part process. We need to create groups for the counties based on some feature, in this case the political characteristic, the Republican change, and assign those categories to each of the counties. And then we have to divide those counties, aggregate the flows between those groups of counties based on educational attainment. So the first step is pretty straightforward, and I won't walk through the code, but based on that Republican change value between the 2000 and 2016 presidential elections, I grouped all of the counties. And so once we've got that done, we can move on. The next step is to aggregate the flows between these groups based on educational attainment. And this part is a little bit more involved. The first thing we need to address is the structure of the table. When you download the data from the US Census, it's organized like this. There is one row for each county pair for each educational group with the number of migrants. And what we need is one row for each county pair with the number of migrants following it. We need columns for each of the educational groups. So let's go to our studio. If I can, there we go. Okay, so I already have a cleaned up version of this data set. It's a little difficult to see, I'm imagining now. But it's just as we discussed. There are multiple rows for each county pair and then the number of migrants for those pairs in each educational group. So the first thing that we need to do is spread the table. So using our handy dandy tidyverse library, we'll spread the table. And now we have all of the educational groups as columns following the county pairs. And to make the table a little more legible, we'll change the column names and fill in all those NAs with zeros. So this is what we have. And since we're mapping the flows based on educational attainment, it's helpful to break up the table into those educational groups. So using these lines of code, we'll break those up into smaller versions for each group. And we can take a look really quick what that looks like. So we have each county pair with the number of migrants in that educational group following it. Then we will import our county categories page, sheet here, and we're looking at this final column here. So the county is listed here. These are other categories that I considered, but this is the one that's important for this. And so here we have in each of those tables the county pair, but what we need is the origin county group and the destination county group, since we're mapping between those groups of counties rather than the counties themselves. So using a key, we'll match each of those. And then finally, we can get to the good stuff, the viz stuff. So using the parsetR package, and these are just one line of code, we get an interactive parset diagram with our migration data. And what's really cool about this is that it is interactive. So you can plug it in, embed it right into a website, and then make adjustments as you want, depending on the style and colors you need. And it's the same for each of these. So the colors do change as you run each one, so have that in mind. But I needed static versions for my thesis, and so I exported these as PDFs and then did all of the editing in Illustrator. Okay, so I will leave you with this. You all know and have experienced how important it is to think creatively about how we map data, even if that means using a not map. So that's all I've got for you. Thank you so much for generously sharing your time with me. And if you're interested in more of the details, you can check out the project website or tweet at me or find me later.